Hi again, everyone. Professor Sebastian. We're on page 35 of our statistics class notes. And I just got done telling you on the previous page that, hey, z-scores allow us to compare observations from different distributions. So let's see how we can do that. As a simple example, example 38, suppose we have two roads. So road A has a mean speed of 60 miles per hour with a standard deviation of 5 miles per hour. And road B has a mean speed of 60 miles per hour, but with a higher standard deviation of 10 miles per hour. Is a driver going 70 miles per hour on road A traveling relatively faster or slower than a driver going 70 miles per hour on road B? So here's what we were just given. Road A has a mean, x bar, 60 miles per hour, standard deviation S of 5 miles per hour. Road B has a mean of 60 miles per hour, but a standard deviation of 10 miles per hour. Although both drivers are traveling at 70, the driver on road A is traveling relatively faster, right? Because 70 miles per hour is 2 standard deviations above the mean on road A, whereas it's only 1 standard deviation above the mean on road B. So that's a more unusual speed. So in other words, it's not as seen as much. So 70 miles per hour will seem faster on road A as it goes blowing by everybody. All right, so formula to convert an observation X to a z-score. The way you convert any data value X to a z-score is you subtract the mean from that X, and then you divide it by the standard deviation S. So let's say, example 39, Maria scored 80 out of 100 on her first stats exam in a course and 85 out of 100 on her second stats exam. So just comparing herself to herself, she would say, oh, I did better on the second exam because I got an 85, whereas on the first exam I got an 80. However, she really should go through and say, well, what was the mean and the standard deviation? Because on the first exam, the mean was 70 and the standard deviation was 10. On the second exam, the mean was 80 and the standard deviation was 5. So the second exam seems to be a little bit easier, and most students did more closer to 80 than on the first exam. The mean was 70, which means it was a little bit harder exam, and there was more spread in that first exam. But what does that mean about Maria's performance? So computing the z-scores for each exam performance, we see that on the first exam, so the data value we're trying to convert to a z-score is 80, right? So x minus x bar over s, so that's 80 minus the mean on that first exam was 70 divided by the standard deviation is 10, which gave us a z-score of 1. On the second exam, computing the z-score, she got an 85 minus the mean of 80 divided by the standard deviation of 5. She also got a 1 of z-score. So the second exam was a little easier, as we talked about up here. On average, students scored higher and there was less variability in the scores, but Maria scored 1 standard deviation above average on both exams because her z-score was 1 for both. So she did equally well on both when compared to the mean.